Let's talk about mass and weight. Uh-huh. Mass, oh, very important. Let's say mass 100 kilograms, which is one, pretty big size guy. Okay, so which is 220 pounds. Okay, so hey, let me draw one picture right here. The Earth. Let's talk about mass first. Okay, this is the Earth right here. Okay, somebody who's right here, right outside of the Earth, right? From the center, okay, usually about 6,500 kilometers away, okay, 6,500 kilometers. So let's say somebody's in air, so twice far away from the center, okay, which is 13,000, okay, let's say 13,000 kilometers away. Mass here 100 kilogram. That's it. What about here? 100 kilogram. That means, okay, even if you go to the moon, okay, still same amount of mass. So what about weight? You remember weight was ma, which is, in this case is gravity, which is g, mg. Okay, so you just multiply 9.8, so which is 980 newtons. You remember that? Okay, that's why right here, okay, we're talking about that weight was right outside of the Earth, which is 980 newtons. What about twice far away? So you go further and further, go away from the center of the Earth. Then you're going to be lighter and lighter. See? You lose weight. If you live on the North Pole right here or South Pole, okay, then you're going to be heavier than somebody who's in the equator. See? Equator far away. See? This is like Earth is like oval shape, just like this one. That's why so somebody who lives in equator, then lighter. So the problem is how much lighter? Okay, let's talk about this one. Okay, this is also twice far away. Okay, so that means that instead of 980 newtons, okay, 980 newtons, divide by then distance. Okay, twice means then twice square. See, which is 4 times, okay, lighter. So here's going to be only 265 newtons. Now you can count on the work, how much work you did. Okay, so work that, okay, we use joule. See how many joules? Joule actually like this one, okay, Joule, that's joule. So each joule actually you just multiply this weight, which is a newton, how many newtons and how many meters. See, so you have to move. That's what we call talking about work. Okay, so that means simply we can multiply newton and how many newtons and how many meters. That's it. Okay, if you move 1 newton, okay, weight, okay, so 1 meter, so we call 1 joule. That's it. Okay, even if you have a lot of work, okay, just like this one, so you have 100 joules, 1,000 joules, whatever, you're not going to do anything, okay, so then you're going to do this one in how long? Say how many seconds? Then somebody can do this one within 1 second or 2 seconds, whatever. Okay, that's why power is watt. Okay, so watt is W-A-T-T. Okay, so in this case, so watt equals, which is the power, equals, okay, joules divided by how many seconds. So as you see this one, so 1 watt, okay, so which is 1 watt, which is power, okay, means 1 joule per second. So that means, okay, you have 1 joule, so you did within 1 second. That means 1 second, that means we call 1 watt. Then let's talk about this guy. Okay, 100 kilogram. Oh, then weight is 980 newtons. Okay, 980 newtons, you move, let's say, 1 meter. Okay, 1 meter. Then we call what? That's right. You just multiply this one, 980 joules. See? Work. Now, then 980 joules in 1 second, that means 980, okay, joules per second, which is, we can write this one like this, okay, joules per second, which is same as what? Watt. That's it, 980 watts. That means you're taking longer, okay, let's say you took 2 seconds, that means you have to divide by 2, right? That means, okay, so if you take 2 seconds, okay, 980 joules, okay, divided by 2 seconds, which is 490 watts. See, less power.